Hi, it's time for another math easy solution. Turn discuss further into applications of integrals and look further into moments and centers of mass. And now we'll go over example 4 of the example series. And look at this example, which states find the centroid or center of mass of the region bounded by the line y equals x and the parabola y equals x squared. So we should graph this first to get a better idea of this region, but first what I'm going to do is basically set y equals x equal to y equals x squared, so we could find where the x values, where the curves intersect. So if we do that, we'll have x equals to x squared. This is a quadratic equation here. If we move this over to the left side, what we end up having is 0 is equal to x squared minus x. Then if we factor out the x, we get x minus 1. So this is only true when we find the roots. So basically the roots are when the x values that we get 0 on the right side. So it has equal to 0 here. So that is when x equals to 0, where we have the 0 times whatever. And then when x is also equal to 1. So when x is 1, we get 0 times 1, which is 0. So these are the roots, and that's when they intersect. And basically at x is 0, we have y equals to x equals to 0, and y equals x squared equals to 0 squared, again equals 0. And then just for completeness sake, the second one, at x equals to 1, we have y equals to x, which is 1, and y equals x squared equals to 1 squared equals to 1. So those are the points, and if we were to graph this region out, we get something that looks like this. This is x, this is the y function here, and now this, we get a straight line like that. This is our y equals to x line. And then this basically from 0 to 1, so 0 all the way to 1 is when the only points where they intersect. So this is 1 right here. And then the parabola looks something like this. It goes like that, and it goes through. Draw it like that, it keeps going on like that. So that's how the parabola looks, something like that. So this is y equals to x squared. I'll draw this a bit smoother, like that. So that y equals x squared. Now we have, this is the region that we're trying to find the centroid of, and roughly speaking the centroid should be, looks something like over here. I would assume it's over there. So let's just by symmetry looking at it, it looks something like over there, and we'll call this centroid or center of mass C, and it has points, coordinates x and y with the line above indicating its center line. And now, basically, to solve this, again, we're just going to recall the formulas that I derived in my last video, and this is bounded by two curves, so we have to use that formula, that more general formula for the centers of mass. So recall centers of formula, or center of mass formula. So centers of mass or center of mass formulas. Not sure if you use plural or not, but anyways. Recall from my last video, I showed that x, the center of mass and x coordinates equal to 1 divided by the area of the region, and then this is from A to B, where in our case it's 0 to 1 of, now we have x times f of x minus g of x dx, like that, and this coordinate, the y coordinate, is going to be 1 over a of integral from 0 to 1, that's a and b, of 1/2, and then we have f of x squared minus g of x squared, and then dx, like that. In our case, basically, where we have y is equal to, f of x equal to x, that's the top curve, and the bottom curve is g of x equal to x squared, like that. And now the area, so a is equal to the area of the region, and again, like I explained in the last video, this area is simply the integral from 0 to 1 of f of x minus g of x, like that, dx. And now we just plug those in, we get integral from 0 to 1 of x minus x squared dx, and then integrate this equals 2. This is just x squared over 2 minus x cubed over 3. Just from 0 to 1, this equals 2, plug in the 1 inside, 1 over 2 minus 1 over 3, then plug in the zeros, those are just zeros, ignore that. So now we multiply by the common denominators, in this case 2 over 2 and 3 over 3, so we have a 6 at the bottom. Well, what we end up getting is a 3 minus 2 over 6, which simply equals to 1 over 6 as the area. So that is our area, 1 over 6. So now let's solve for the x-coordinate of the center of mass. That's this formula here, which is going to be equals to 1 over the area, which is 1 over 6. Integral from 0 to 1 of x times, this is going to be f of x minus g of x, or otherwise write it as x minus x squared dx. And now this equals to this 1 over 6 flips over, so we just get 6. And now integral from 0 to 1, multiply this out, x squared minus x cubed dx. And now this equals to, when we integrate this, 6, this is just x cubed over 3 minus x4 over 4. This is 0 to 1, evaluating it. So when we evaluate it, we get 6, plug in the 1s, 1 over 3 minus 1 over 4. And now the common denominator of this, well, let's just multiply both these denominators together. So this is by 4, 4, 3, 3, so the common denominator is 12. So what we end up getting is 6 times 4 over 3. Divide this by 3 times 4, the common denominator, and just put it like that. We'll also just multiply this out. So this is 12. Like that. So this is 1 over 6 over 12. This becomes 1, this becomes 2, and this becomes all 1. So that's just going to be 1 over 2. So the x-coordinate is simply 1 over 2. So now let's just find the y-coordinate. The y-coordinate uses this formula over here. So let's plug that in. And again, for f of x is x, this is x squared for g of x. So what we end up getting is the y-coordinate of the center of mass is 1 over a, which is 1 over 6, integral from 0 to 1 of 1/2, and then we have this x squared minus x, this is going to be x squared squared, which is x, yeah, let's write that down actually. So we have this x squared and then squared, which is simply x to the 4 dx, like that. So let's expand this further. This is 1/2. So this is 1/2. Put the 6 above to take the constant out of the common denominator. So we have this 6 over 2, like that. Integral from 0 to 1 of x squared over x4 dx. And now let's just solve this. This equals 6 over 2 is 3. Integral is x cubed over 3 minus x5 over 5. 0 to 1. This equals to 3 times 1 over 3 minus 1 over 5. And now the common denominator here, times by 5, times over 5, sometimes by 3. Actually, whoops, other way around actually. This is times by 5. So we get a 15 at the bottom, because it's all some other common denominator there. This is 3, 3. So we get now is a 3 times, this is going to be 5 minus 3. And the common denominator here is 3 times 15. I'm just going to keep the 3 times 5, and 3 times 5 is 15. I'm going to keep the 3 there because we have this 3 out here, so this cancels, and this is going to be equal to 5 minus 3 is 2 over 5, and this equals to the y-coordinate of the center of mass. Yeah, I'll just write this better. So thus what we have is thus the centroid the centroid is at the coordinates, this is at the coordinates 1/2 and 2/5, and that's our answer, like that. So now if we were to scroll up and just see where we roughly estimated it, so we estimated around there, and this kind of does look like the center here, and this is 1/2, and then this length above here, because it looks a bit weighted more downwards, that's why it's slightly, this one here is at 1, so that's at 1, this is at 2/5, so slightly less than half, where the actual half is here, which is 2.5, so roughly 2.5/5, that's the half, so this is the centroid here and there roughly. So yeah, we guessed it pretty much bang on. Anyways, that's all for today. Hopefully you'll learn from this pretty useful example on how to use the formulas for centers of mass, which I went over in my last video and other videos as well, so make sure to watch those in the video links below. Anyways, that's all for today. Hopefully you learned, and like always, you can download these exact notes in the link below, and thanks for watching, and stay tuned for another math easy solution.